All right, today we're diving into a really important systematic review from JAMA Network Open. It's all about using AI to diagnose sexually transmitted infections. And if you're a researcher working in this area, you're going to want to pay close attention because this is basically a blueprint for what needs to happen next.
So it all boils down to this one huge question. Can an AI actually look at a picture of a lesion and tell you what it is accurately? I mean, the potential here is massive for public health. We're talking faster diagnoses, better access to care. It could be a real game changer.
But what's the verdict? Is it working? Well, it's kind of a mixed bag. The paper finds that yes, the technology has incredible promise. But, and this is a big but, the research behind it is full of some pretty deep systemic flaws that we absolutely need to talk about.
Okay, let's start with the good stuff. What did this huge meta-analysis find when it pulled together all the best studies out there? Where's the promise?
I mean, just look at these numbers. They're pretty incredible, right? For mpox, the AI models had a 96% sensitivity. That means they caught the disease almost every time. And 98% specificity, meaning they were great at ruling it out too. And you see really strong numbers for herpes, genital warts, and scabies as well. So on the surface, you're thinking, wow, this is amazing.
But here's where the first major crack starts to show. That amazing performance? It isn't spread out evenly. Not even close. The entire field of research is tilted heavily, and I mean heavily, towards just one disease.
And this chart right here really says it all. Out of 140 studies, almost 80%, 4 out of 5, were just on mpox. Now, that's kind of understandable because of the global outbreak in 2022, but this laser focus meant that other super common STIs were basically fighting for the leftovers.
So what does this actually mean? It means while everyone was rushing to build models for mpox, a major public health threat like syphilis, which is on the rise globally, was almost completely ignored. This massive imbalance creates a huge blind spot. The technology just isn't being built for the real world.
And that brings us to the real heart of this paper. The authors found more than just one problem. They systematically identified 6 critical gaps that are preventing this whole field from getting out of the lab and into the clinic. This is the roadmap.
So we're going to walk through each of these 6 gaps. We'll talk about the diseases being studied, the data being used, how the models are actually built and evaluated, and all the way to the biggest gap of all, getting these tools into the hands of clinicians.
Now, this might sound a little negative, but here's the brilliant part of this paper. It doesn't just point fingers. For every single gap it finds, it offers a clear recommendation, a way to build a bridge from the flawed research we have today to the powerful clinical tools we need tomorrow. So let's see how we can build that bridge.
So gap number 1 starts with these diseases themselves. Like we saw, it's all about mpox. But even worse, the models are often trained to tell mpox apart from something obvious, like chickenpox. That's not what a doctor needs. The recommendation here is clear. We need to prioritize common STIs like syphilis and herpes. And we need to train the models on a whole range of real-world conditions that actually look alike.
And when all the research is focused on one thing, it leads directly to the next huge problem, the data. That's gap number 2. Almost everyone is using the same few public data sets, and frankly, the quality just isn't there. So the paper calls for a big change. We need coordinated networks to collect high-quality, diverse data with really strict quality control.
And the numbers here are just jaw-dropping. Almost 9 out of 10 studies use these open-source data sets. A lot of those data sets had duplicate images, which messes with the results. And maybe the most important point here, almost nobody, less than 6% of studies, included crucial patient info like symptoms or medical history, the stuff a real doctor actually uses. So if your data has no clinical context, it's no surprise that the models built from it are also disconnected from clinical reality. That's gap number 3, model development. Too many of these are just tech demos with no clear purpose. The recommendation? Start with a clear clinical goal first. Is this a screening tool or a diagnostic tool? And then you have to combine the images with that rich patient data.
And this leads right into gap number 4. How do you even evaluate these models? Well, the truth is, most studies don't do a great job. Almost nobody tests their model on data from a different hospital to see if it actually works elsewhere. And performance is almost never checked across different groups, different genders, different skin tones, different lesion locations. That raises some serious equity and reliability questions.
This lack of good evaluation feeds right into gap number 5, reporting performance. Right now, it's the Wild West. Every study reports different metrics, which makes it totally impossible to compare one model to another. The solution is so simple, it's almost frustrating. The whole field needs to agree on a standard set of metrics to report every single time. Okay, so when you add it all up, the skewed focus, the poor data, the aimless development, the inconsistent evaluation, you get to the final and maybe the biggest gap of all, application. All this research is happening in a bubble. It's not being translated into clinical practice. We're not seeing pilot studies or clinical trials.
And if you need one single number to really understand how massive that application gap is, just look at this: 0.7%. That's right. Of all 140 studies they looked at, only one had moved beyond the, hey, look what my algorithm can do stage. It's a shocking number that shows just how far we have to go to make this real. So after hearing all that, you might be thinking, wow, this field is a total mess. But the authors of this paper see it completely differently, and you should too. These aren't just problems, they're invitations. They're clearly defined opportunities for your next high-impact research project. The paper's conclusion says it best. It's basically a direct call to action. It's telling the research community exactly what to do. Focus on the diseases that matter, fix the data, test your work in the real world, and get it into a clinical setting. And that leaves us with the final question, and this is for every researcher watching right now. You've seen the blueprint and you've seen the gaps. So, which one are you going to fix? Which bridge is your next project going to build? We've really only scratched the surface here. For a much deeper dive, you've got to read the original paper by So and their colleagues in JAMA Network Open. It is an absolutely essential read. Thanks so much for watching.